Hi guys, my name's Raz. Today we'll be looking at proof. So this is a bit of a tough one to go through, explain. So I'm going to just give the background of a couple of things, and we're just going to dive into some examples, and hopefully you understand it by the end of it. So firstly, how do we make any number, let's call that number n, even? If I consider a number n, I do not know if it is odd or even. Yeah. If we double any number, it will be even. Yeah. So if you think about the 2 times table, all the numbers are even. Hence, that is even. Yes, that is the first trick that we'll use. And the second one is that once you've got an even number, you can make it odd by either adding 1 or minusing 1. So you look at this number, for example, 2. 2 plus 1 is 3, which is odd. Take another even number, 100. 100 plus 1 is 101, which is odd. So if you add an odd number to an even number, you'll always get an odd result. Yeah, and if you take away an odd number from an even number, you get an odd result. But we will use 2n plus 1. Yeah, so that will be what we use, or 2n minus 1. So if we had any number we wanted to make it odd, we would double it, then add 1. And if we had a number we wanted to make sure it was even, we would simply double it. Yes, those are the key principles, what we're going to do. So example 1, prove algebraically the sum of 2 consecutive integers is always an odd number. So this one is a straightforward question, but I'm going to show you how to structure work. So the first integer would be, an integer just means a number. Yeah, it's a fancy way of saying a number. The first number, let's say, is x. Well, if they're consecutive numbers, they go up by 1 each time. So the next one must be x plus 1. So if we say consider x and x plus 1, then x plus 1 is equal to 2x plus 1. Yeah? Since 2x is even, 2x plus 1 is odd. Job done. That's what the square means. Job done completely. Right. If you're not that gangster, you can write as required. So, next. Prove algebraically that the sum of 3 consecutive even integers is always multiple of 6. So what must our first even number be? Yes, 2n, x, m, p, q, whatever letter you can use. I'm going to go with n for this one. So if 2n plus 1 is odd, what would the next even number be? That's right, 2n plus 2. And the next even one after that? No? That's it, 2n plus 4. If they're consecutive, that means they're one after the other. So now, we're considering those, then we're going to add them because it says the sum, and sum means add. So 2n plus 2n plus 2 plus 2n plus 4, that will give us 6n plus 6. Now, that shows clearly that I understand. Yeah, pull out that factor of 6. I see that it's a multiple of 6. Yeah, you ain't gangster enough to put the square, then right. Therefore, 6n plus 1 is a multiple of 6 as required. Yeah. Right, next. Prove that 3n plus 1 squared minus 3n minus 1 squared is always a multiple of 12. Now, this is an expanding brackets trick. Yeah, so we need to do 3n plus 1 squared. And we need to consider 3n minus 1 squared. So first out to inner last, we're going to get 9n squared plus 3n plus 3n plus 1, which is 9n squared plus 6n plus 1. And here, when we do first out to inner last, we're going to get 9n squared minus 3n plus 1, because minus 1 to the minus 1 is positive 1. So 9n squared minus 6n plus 1. Now, the common mistake will be when subtracting. Yeah, we need to minus the whole thing. So that negative sign will act on everything. So we will have 9n squared plus 6n plus 1 minus 9n squared plus 6n minus 1. Yeah, because that negative sign hits everything in the bracket. So the 9n squareds cancel, the plus 1 and the minus 1 cancel, and we're left with 12n. How do I show that's a multiple of 12? Let's state the obvious like that. Job done. Oh, that's about square. Job done. Give me more. This guy. Nope. So n is an integer. Prove algebraically that the sum of n plus 1 and n plus 1 is always a square number. Sum's easy. So we've got n. Consider n plus 1 and n plus 1. Boom. N squared plus n and n plus 1. We want the sum. So then n squared plus n plus n plus 1 equals n squared plus 2n plus 1. Can you see what the next bit is? Yeah, let's factorize it. We get that, which is clearly squared. Boom. Get out of here. All right, let's do one more. One more for luck. So prove that that is always a multiple of 12. Let's go. 2n plus 3, 2n plus 3, 2n minus 3, 2n minus 3. First, outer, inner, last. 4n squared plus 6n plus 6n plus 9. 4n squared plus 12n plus 9. Let's do this one first, outer, inner, last. 4n squared minus 6n plus 9. 4n squared minus 12n plus 9. Use brackets properly. Let's subtract. Like that. Expand that out. We've got 4n squared plus 12n plus 9 minus 4n squared plus 12n minus 9. 4n squareds cancel. The 9s cancel, and we're left with 12n plus 12n. That's 24n. How do I show that is a multiple of 12? Let's take the 12 out. 12 times 2n. Job done. Your uncle. See you later.